Hello friends, welcome to the basic electronics module another new chapter. So today in this lecture we will see the diodes. That what are diodes, their working principle, different types, their application, advantages and disadvantages. So let's start our today's topic. I have divided this particular topic in four sections. In first section, we will be introducing to the diodes, the history of diodes and its definition and its symbols. Then we will see the working principle of diodes, means on which principle the diode work. Then after in third and fourth section, we will see the different types of diodes we will use or we are using in day-to-day life. So guys, let's start with our first introduction part. So, what are diodes and the history of diodes? So, semiconductor diodes are the first. I mean, you can say these are the first semiconductor electronic devices. So, semiconductor diodes were the first semiconductor electronic devices. The discovery of asymmetric electrical conduction across the contact between a crystalline mineral and a metal was made by German physicist Ferdinand Bruhn in 1874. Today, most diodes are made of silicon, but there are other semiconductor materials used such as gallium, arsenide, and germanium. So, let's see the definition of diode. That what a diode is. So, this is how your diode in practice or in real life looks like. This is a image representation of diode. So a diode is a two-terminal electronic component that conducts current primarily in one direction. So diodes, the you can say the primary or main function of a diode is to conduct or to let flow the current in only one direction, which is asymmetric conduction. It has low means ideally zero resistance in one direction and high means ideally infinite resistance in the other. Diodes are used to protect circuit by limiting the voltage and also to transform AC into DC. See, as we have seen in the definition of diode, that diode's main function is to flow or conduct the current in only one direction. So a diode lets current to flow in one direction, means it will constant or it will regulate the flow of current. So the diodes also used as or you can say to transform the AC into DC, means alternating current into direct current by neglecting or by cancelling the difference or you can say the change in current. So they are used as AC to DC converters and also used to limit the voltage. Semiconductors like silicon and germanium are mainly or widely used to make diodes. Now we will see main function of diode, that what are the main functions a diode performs. The most common function of a diode, The most function, the most common function of a diode is to allow an electric current to pass in one direction only, and that one direction is called forward direction, while blocking it in the opposite direction, which is you can also say as a reverse direction. As such, the diode can be viewed as an electronic version of check valve. This unidirectional behavior is called rectification. Means it allows to flow through in only one direction and blocks the current into the another, or you can say in reverse direction. So this unidirectional behavior is called rectification and is used to convert alternating AC current to direct current DC. As rectifiers, diodes can be used for such tasks as extracting modulation from radio signals in radio receivers. So this was the basic function of a diode, which is to convert AC into DC. Now, making of diode. Diodes can be made of either silicon or germanium. When the anode voltage is more positive than the cathode voltage, the diode is said to be forward biased and it conducts rapidly with a relatively low voltage drop. So when a diode is in forward bias, there is a negligible, or you can say low voltage drop. Likewise, whenever the cathode voltage is more positive than the anode, means reverse condition, the diode is said to be reversed biased. The arrow in the diode symbol represents the direction of conventional current flow when the diode conducts. So this is the representation of diode. This is the demonstration. This is how your real life diode looks like. And this is the schematic representation. Whenever there is a diode in a circuit, this is how we represent it. And this is how we represent a diode in some diagrams. These are used in diagrams and these are used to denote a diode. So basically what happens in a diode, there is a P region, means there are holes of positively charged, means this region is highly positively charged, and this n type of region will have a number of, or you can say maximum number of free electrons. So this will said as n type region. This n type region is cathode and this side is called as anode, and in between them there will be a junction formed whenever there is you can say this diode is connected to a battery or any power supply. There will be a formation of pn junction. So this is denoted here, which is small region. This is anode, and anode is positive terminal and cathode is negative terminal. So in symbolic representation, the arrowhead, you can say this, you can see the side of arrowhead is always an anode, which is positive terminal, and the vertical line, the only straight vertical line, suggests the cathode side or negative terminal. Or in other words, you can say the white stripe indicates cathode. This white stripe is cathode side and this is anode side. So this is an anode, this is cathode side, this is anode side, this arrowhead. There are two terminals of a diode that are known as anode and cathode. The arrowhead, the arrowhead is anode that represent the direction of conventional current flow. So whenever diode is charged or in forward bias condition, the current will flow from this anode to cathode. So this is the conventional current flow direction. The direction of the conventional current flow in forward bias condition. The other end is cathode. So this is the cathode terminal. Now let's move forward with the working principle of diode. So in this section, you'll learn the basic working principle of diode and their characteristic, which are forward, reverse, and zero biased. So let's see the working principle first. So there are two parts for a diode, that how does a diode work, or you can say its working condition, and how a diode cannot work, means non-operating region. So when a diode is connected to a battery, see here, this is the battery. This is how in schematic representation or in diagram a battery is represented. So the longer terminal, or you can say longer vertical line, represents the positive terminal, while this shorter vertical line is represents the negative terminal of battery. So this is the positive terminal of battery and this is the negative terminal of battery. So whenever a diode is connected to a battery like this, means this, the positive terminal of battery is connected to p type or arrowhead of your diode, and negative terminal is connected to the cathode or vertical line of your diode. Means this is the battery, this is the two types of your diode. This one is p type and this one is n type. Whenever the p type is connected to positive terminal of battery and n type, this n type is connected to the negative terminal of battery, and the field is supplied by the battery, then it is called a forward bias condition. The electrons and holes combine, causing the current to pass through the diode. So whenever there is a battery connected to a diode in this way, there will be some combination. The holes The holes in this region, the free holes in this region will attract to the center, will be come here, and the electrons, the majority charge carriers electrons from here will attract here, and in this center they will form a junction, and due to which the current can pass through this. So this is how the current flows in forward bias condition, and this is called a forward biasing of a diode. So it is said to be, when a diode is arranged in this way, it is said to be a forward bias. So in forward bias, there is a current flow and low voltage drop. But what if when the diode is not connected in that way and it is connected in the reverse way? So let's see how does not a diode can work. When a PN junction is connected across battery in such a manner that its N-type region is connected to the positive potency of the battery, and the P-type of region is connected to the negative potency of the battery, something like this. See here, this is the battery, positive terminal of battery, this is the negative terminal of battery, and positive terminal of battery is connected to the N-type of your diode, and negative terminal of the battery is connected to the P type of diode. Now, in this case, the depletion region, the region between these two is the depletion region, and this is also called as a barrier. Now, the length of this barrier is very high that a current cannot pass through it or goes beyond it, and hence in reverse bias condition there will be no current flow, or the current cannot go through this diode, and hence the diode blocks the current, in other words. So the diode blocks current in the reverse bias condition. Ideally, there is no current flow through the junction, but practically there will be a tiny reverse bias condition. So you can, when it is ideally, or it is calculated in ideal terms, there will be no current flow or zero current through this. But in practical, in real life diodes, there will be a tiny reverse bias currents, but which you can neglect, a negligible reverse bias current. Let's see the characteristics of diode. So the following are the characteristics of diode, which are forward bias diode, reverse bias diode, and zero bias diode. In forward bias, there is a small drop of voltage across the diode, as we have just seen, when the diode is forward biased and the current is conducting. For silicon diode, the forward voltage is 690 milliwatts, and for germanium, it is 300 millivolts, is the forward bias voltage. The potential energy across the P-type material is positive, and N-type it is negative. While for reverse biased diodes, what happens? A diode is said to be reverse biased when the battery's voltage is dropped completely. For silicon diode, the reverse current is minus 20 microampere, and for germanium, it's minus 50 microampere. The potential energy across the p-type terminal is negative, and across n-type it is positive. So in reverse bias, the connection is reversed. At p-type terminal, the energy is negative, and at n-type or in n-type material across, it is positive. So it is called reverse bias diode. While in zero bias diode, so when the diode is zero biased, the voltage, or you can say the potential across the diode, is zero. So this is the graphical representation of the characteristics. This is forward biased diode characteristic, and this is reverse biased diode characteristics. This is current versus voltage graph. So in forward bias, as the voltage of battery increases, the forward bias current increases. So this is the graphical representation when diode is connected in forward bias condition. So the as voltage increases, the current increases rapidly. You can see here. Here for some voltages it is almost zero, but after a certain amount of voltage, the current of forward bias increases rapidly. You can say exponentially. This is reverse bias diode. What happens in reverse bias? There will be no means there will be current, but it will be negligible. So it is in negative quantity. And see, with increase in voltage, for some voltage it is negligible, but after some reverse bias voltage there is a major increase in current. And this is VI characteristic of a whole diode. This is a forward region and this is reverse region. This is forward and this is reverse. So this is how a VI characteristics of diode you can achieve. Now let's discuss some of the applications of this diodes, where these diodes are used. So as a full wave or half wave rectifier you can use a diode. AC to DC supply you can use a diode. In logic gates, you can use a diode. In clamping circuit, in reverse current protection, and in clipping circuit, you can use diodes. So now let's move forward to our third part of this lecture, which is types of diodes. So in this particular section, we will see the different types of diode which are majorly used. So from the list, first we have light emitting diode. So basically light emitting diode performs a task of emitting light. So the name itself suggests that it is a diode which emits light. So the main purpose or main function of this diode is to produce or generate light whenever there is a current flowing through it. So when an electric current between the electrodes passes through this diode, light is produced. Or you can say in other word, it generates light when a sufficient or a specific amount of forwarding current only in forward direction. So whenever this type of diodes are connected in forward bias condition and there is a sufficient amount of current passes through the electrodes, and then this diode emits light. So this is the picture representation of light emitting diode. Here as you can see, the LED has two terminals or two legs. Whenever current flows through this, so the longer one is called anode and shorter one is called cathode. We will see this in a particular different lecture, but here this is the pictorial representation. Here this is the short form, or you can say abbreviation for this is LED. And I know you most of you will know this LED, and we have used this LEDs so many times in our day-to-day life. So this is a red LED. So whenever there is a current flow between anode and cathode, this diode will generate, or you can say produce or emit red light. Specifically, this will produce white light and this will produce blue light. So this is a pictorial representation of light emitting diode, which does nothing but emits light whenever there is a current flow between the electrodes of them. Now here as you can see, this is the schematic representation. So whenever there is a circuit diagram, this a kind of diode, or you can say LED, are denoted by this picture, this representation. So this is nothing but a simple diode, and around this there is a circle and there is an arrow outside. Arrow outside suggests that it generates or it emits or it gives out light. So this arrow suggests that it gives out a light as it functions. So this is how the schematic representation is done for light emitting diode. So now let's see the different applications. As you all know that these LEDs are widely used in decorative purpose, and we have seen these series lights. So in our home or anywhere we have the application of lights to for decorational or decorative purpose. We use this kind of series LEDs. And another applications are visual signals. They are used in visual signals where light goes more or less directly from the source to the human eyes. Means not directly projected into eyes, but they goes more or less it directly to convey a message or something like that. It illuminates or illumination where light is reflected from objects to give visual response of some objects. And they are also used in measuring and interacting with processes. involving no human vision, and narrow band light sensors where LEDs operate in reverse biased mode and also respond to incident light instead of emitting light. So these were some of the applications. Majorly they are used to illuminate illumination purpose and for decorative purposes. Now let's see its advantages. So advantages are like including low power consumption. So it has low power consumption and comparatively longer lifetime, and it has improved robustness, and they are smaller in size and faster in switching. So these were the you can say these were the applications and advantages, main advantages of the LED, or you can say light emitting diode. Now the second of this list is laser diode. So laser diode. So first of all, we will see what is laser. So laser is an abbreviation, not a single term, but it is an abbreviation for light amplification by stimulated radiation emission. So laser stands for light amplification by stimulated radiation emission. So laser diodes are nothing but these are the diodes which are specifically used for projection of light in the form of beam. I know you guys already have some idea about it, but so laser is nothing but a beam projection of light. So it is a different type of diode as it produces coherent light. This coherent light is produced by the process of light, you can say light emission amplification. It does nothing but it amplifies light by stimulated radiation emission. It uses a process called stimulated addition. Radiation emission. There are now there is a drawback of it, which is it is a expensive, or you can say costly compared to LEDs, the light emitting diodes. So these are not cheaper, but these are expensive, or these are higher in price compared to LEDs. But when you compare it to laser generators, they are cheaper. So these laser diodes are expensive than LEDs, but they are cheaper when compared to laser generators. Now limited life is the only drawback. So you can say this is the second drawback. This is a kind of drawback which is like it has limited life, means you cannot use it as a LED rough and tough, but it has comparatively low lifespan. So this is the pictorial representation of your laser diode. This is how your laser diode looks like. These are the two terminals, or you can say two ends of this diode to which you can connect a power source. This stands for positive connection and this is for negative connection, and this is the space from where the amplified beam of light goes out from. Now, below this pictorial representation, there is a schematic representation of laser diode. So this is how your laser diode is represented in graphical form, or you can say circuit diagrams. So each and every diode has this arrowhead almost, and the arrowhead suggests nothing but anode, and this vertical line or the area after arrow is cathode. So this is anode terminal, this is cathode terminal. Now it has a circle, but it has two arrows. This representation or this drawing particularly has two arrows, while in case of LED there is only a single arrow. So whenever there is a single arrow, it denotes or it represents the schematic representation of LED. While where there are two arrows, this denotes laser diode representation. So in laser diode, there is a simple diode and there is also a vertical line added over here, and the circle around it and two arrows going out of this circle. Means this is a diode which is able to produce lights or give out the light. Now let's see the applications of these diodes. Now the laser diodes are highly used in CD drives, DVDs and laser devices.
because of the disadvantages, and the advantages are it operates at lower voltage and gives higher power output. So it consumes low voltage, means it requires low voltage, means it operates on comparatively low voltage compared to the other diodes, and in return they gives higher power output compared to the other diodes. Now they have higher efficiency and also they are smaller in size. So because of this advantages, they are used in laser printers, barcode readers, security systems, fiber optic communication, and light beam illumination. So these are the applications area of laser diode. Now the third category, or you can say the third number, is of avalanche diode. So avalanche diode, this is this pictorial representation of your avalanche diode. So basically, avalanche diodes are an avalanche diode is a type of semiconductor diode which is designed to experience avalanche breakdown at a specific reverse bias voltage. So this is something which operates in reverse bias condition. So these are the diodes, or you can say a type of semiconductor device which is designed to experience the avalanche breakdown at a specific reverse bias voltage. Now these diodes allows electric current in reverse direction when reverse bias voltage exceeds the breakdown voltage. So these type of diode do the main function is they allows electric current in reverse direction when reverse bias voltage, the value of reverse bias, the value of voltage increases or goes beyond the reverse bias voltage at a breakdown voltage. So this is the main function of avalanche diode. This diode belongs to reverse bias types and operates using the avalanche effect. When voltage drop is constant and is independent of current, the breakdown of avalanche takes place. They exhibit high level of sensitivity and hence are used for photo detection. So this type of diodes are used for detection of photos, or you can say for photo detection. So this is how the different types of avalanche diodes looks like. Now its application range and advantages are to remove the negative signals from AC current. So they are mostly used to remove the negative signals from AC current, and mostly they are used in radio as a filtering system. So in radio they are used as a filtering system in order to extract the radio signals from carrier wave. So where the carrier wave has radio signals, so these kind of diodes are used to extract the radio signals from the carrier wave, and the purpose of them by the means of filtering system. So they are used in radio as a filtering system. Now few advantages of them are they operates at low voltage and they have higher quantum efficiency. They are also smaller in size and also they have lower sensitivity to magnetic fields. So this is one of the main advantage, you can say, which is they have lower sensitivity to the magnetic fields around them. So this was about avalanche diode. Now let's see the fourth type of diodes, which are Zener diodes. Now Zener diodes are widely used, or you can say these are the diodes which are mostly used in our day-to-day life and so many different devices. So it is the most useful type of diode as it can provide a stable reference voltage. So these are the diodes which provides a stable reference voltage. So they, because of this function of, or you can say this particular advantage, they are mostly used. These are operated in reverse bias and breakdown on the arrival of a certain voltage. If current passing through the resistor is limited, a stable voltage is generated. So whenever there is a current flow through the resistor is limited, then a stable voltage is generated. So Zener diodes are widely used in power supplies to provide a reference voltage. So these kind of diodes are used in power supply. Power supply modules uh, have they have this kind of Zener diodes to provide the reference voltage. A Zener diode is a special type of diode designed to reliably allow current to flow in backward, or you can say inverted polarity, when certain set reverse voltage, which are also known as Zener voltage, is reached. So they perform this kind of function when a certain set voltage, or you can say Zener voltage, is reached. They allow current to flow in backward direction. So this was the main function of a Zener diode. And this is how your Zener diode looks like. This is a pictorial representation of a Zener diode. Now it's schematic presentation. These are the Zener diodes, but in schematics, or you can see in circuit diagrams or a graphical representation, they are denoted something like this. So this arrowhead represents anode, and this side represents cathode. In Zener diode, as its name has Z in the first as a first letter, here you can say something like Z. So from this you can say it is a Zener diode. So Zener diode is represented by this, and current is flowing through cathode to anode. See here, this arrow is current is entering from the cathode side. So the Zener diode current is has this negative polarity, because the conventional flow of current is from anode to cathode. But here the arrow is represented in the direction of cathode to anode. That's why this current is denoted or has the negative sign. Now the application area or the applications of the Zener diodes are waveform clipper. They are used as a waveform clipper, voltage shifter, and voltage regulator. So they are used as a voltage regulator and voltage shifter, and also as a waveform clipper, as they you can say as they blocks or as they allows AC current in backward direction. Now, our fourth and last part of this lecture, or this diode session, is also types of diodes. In this section particularly, we will see the another types of diodes. And first is Schottky diode. So Schottky diode has lower forward voltage than the other silicon PN junction diodes. See, the other PN junction diodes has not this much of lower forward voltage. So these Schottky diodes are preferred where there are lower forward voltage are required. The drop will be seen where there is low current, and at that stage the voltage ranges. So at that stage the voltage range would be between 0.15 to zero point 0.4 volts. So these are constructed differently in order to obtain that performance. So in order to get this voltage range, they are constructed differently from the other diodes, and these are widely used in rectifier applications. Wherever there is a requirement of rectification, this kind of diodes can be used. So its application area are as a voltage clampings, sample and hold circuits, and charge control. Now the second type is photodiode. As its name has a photo, means these are you can say this has a high sensitivity when exposed, when they are exposed to light. So it has a sensitivity towards light. Whenever whenever the light falls onto them, they have the higher speed of operation. So this is a photodiode, and also another kind of PN junction diode. It consumes light energy to produce an electric current. So whenever there is a light falls onto it, it produces electric current. This is the main function of photodiode. They are also called a photodetector or light detector or a photo sensor, as it sends lights falling onto it. So they are also known as photosensor. Photodiodes are designed to work in reverse bias condition. Also, this is the one of the types where they operate in reverse bias condition. Typical photodiode materials are silicon germanium and indium gallium arsenide. So these are the materials from which a photodiode is made, and these are silicons, germanium, and indium gallium arsenide. A photodiode can identify even a small amount of current flowing resulting from the light. So whenever there is a light, means it detects a smaller amount of current. Even a small amount of current flows resulting from the light, it can sense it. So these are very helpful in the detection of light. So they are used to detect lights. This is a reverse bias diode used in solar cells and photometers. So this kind of cells are generally used in solar cells and photometers. They are even used to generate electricity, and many a times they are used as a electricity generators. So this is how a photodiode looks like. So the you can as see, this is the photo representation or pictorial representation of photodiodes, and this is the schematic representation. So in schematic representation, you can see that it has reverse arrow direction over here. In LEDs and you can say laser diodes, the arrows were outward side, and here the arrow's direction is an inward direction, means the arrows are coming to this arrowhead. Okay, so this kind of diodes are known as photodiodes. This is anode side, this is cathode side, and whenever light falls onto it, they detect the light. So this is how it is represented as a photodiode, means whenever there is light, they will start performing their operation. So in photodiodes, the arrow is in inwards direction, and for LEDs and laser diodes, which generates light, the direction of these arrows are always in outward direction. It senses the light, hence the direction of these arrows are in inward direction. Now let's see the applications of this kind of diodes. So they are used in solar cells, in logic circuits, indoor cultivation, and including cannabis. In the and also in the detection circuits, they are used. In character recognition circuits, they are faster and more complex. Hence are frequently used for lightning regulation and optical communication. So this kind of diodes are also used in lightning regulation and optical communication. Used for the exact measurement of the intensity of light in science and industry. So this kind of cells are used for the measurement of intensity of light in science and industries. Let's see the advantages of photodiodes. So it has higher operating speed, means the photodiodes operates on higher speed, and also they are have also they are cheap, or you can say they are low cost devices or diodes. Quick response when exposed to light, lightweight and compact size, and also wide spectral response. So these are the advantages of photodiode. Now let's see third type, which is PN junction diode. So what is a PN junction diode? So this is the schematic representation of a typical PN junction diode. So P and N. So P stands for, so these are nothing but the two materials used to form a diode. And there is also a junction, that's why it is named as PN junction. P stands for positively doped material, and N stands for negatively charged electron material. So in this kind of material there would be a maximum number of holes, and in this kind of material there will be free electrons in maximum number. So this is p type and this is n type. In this p type there are more number of holes, and in this n type side there are more number of electrons. And the this line in blue color is nothing but junction formed whenever there is a voltage connected to it. So the PN junction diode is also known as rectifier diode. As we discussed earlier in this lecture, in the starting or initial stage, that what is diode? The you can say the definition or the main function which of diode, which is to block current, or you can say block AC current, and it only allows DC, or you can say it allows current to flow through only in one direction. So this is kind of one way. Diodes are referred to as a one way device, means it allows current to flow only in one direction, and it resists or blocks the current in the opposite direction. Means whenever the current is flowing in the one direction, it will allow it to pass. Means at that time there will be kind of an ideal diodes, there will be like no resistance or zero resistance, and in other direction there will be infinite resistance, and due to which it blocks the current in that particular reverse direction. So these are also known as rectifier diodes. These diodes are used for the rectification process and are made up of semiconductor material. So in this, two types of semiconductor materials are used. The PN junction diode includes two layers of semiconductors, two different layers of semiconductors. One layer of the semiconductor material is doped with p-type material. So over you can see over here, this region is highly doped with p-type material, and this layer or this side is highly doped with n-type of material, and hence it is named as PN junction. PN junction diode. So let's see the application area of this kind of diodes. So these are used as a photodiodes, as the diode is sensitive to the light when the configuration of this diode is reverse bias. So whenever these are configured, or you can say these are in reverse bias condition, they are used or they can be used as a photodiodes. And they are also used as a solar cell. When the diode is in forward bias or is forward biased, it can be used in LED for lighting applications. It is also used as a rectifier in many electric circuits, as a voltage controlled oscillator in varactors. And so these were the applications of PN junction diode. So thank you so much all. This was all about diodes and their types, its working principle and advantages and applications. So thank you. We'll see you in the next lecture.